If you set out white-faced like a chicken to travel around the solar system, how long would it take to visit each planet? First, with current technology, how many days do you think it takes to reach the moon? You're right, only 3 days. But what about other planets, like Mars, Jupiter, or Pluto? How long would that take? 1 month? Or 1 year? Hello, solar system travelers. Welcome to the Old My Exploration Society. The interstellar journey ahead will show you exactly how long it takes to reach every planet. I don't know if you feel the same, but when I see the simplified solar system diagrams in science videos, the solar system seems small, just a few little balls. But in reality, even going to the relatively close Mercury is dozens of times farther than a round trip to the moon. Today, I'm throwing you into these places so you can directly experience how mind-blowing it is to check in on every planet of the solar system. First, you must understand that driving in the solar system is nothing like what you imagine. You think the navigation destination is fixed, right? But in reality, every stop, every planet, is moving, and moving at different speeds along elliptical orbits. If you head straight toward where your target planet is right now, there will only be one result. By the time you arrive, it will already be long gone. So what do? Veteran cosmic drivers have a solution: the Hohmann transfer orbit. It isn't a simple detour, but a precisely calculated golden route that uses the least fuel to let you and the planet meet in space at exactly the right moment. The other method, is the gravity assist, which steals a bit of orbital energy from a passing planet and slingshots you forward like a catapult, without burning a drop of extra fuel. Once you master these two subjects, you finally earn your interplanetary driver's license. So first stop, Mercury, the closest planet to the Sun. You think the Sun's gravity should make it the easiest to reach, right? On the contrary, this tiny, unremarkable-looking planet is the solar system's childhood time capsule. Beneath its cratered surface lies an active metallic core and even a strong magnetic field. Even more shocking, scientists suspect it may once have had liquid water, which means it might have had a chance for life. But touching this planet is harder than going to heaven. Even if you fly toward Mercury at the Parker Solar Probe's insane speed of 692,000 kilometers per hour, it still takes more than 4 months. Why so slow? Because Mercury's orbit is unserious. Its distance from Earth changes constantly. Even worse, its orbit is the most tilted in the solar system, making navigation extremely complicated. Humans invented space ballet to deal with it. No probe can ever fly straight there. All must rely on gravity assists. Mariner 10 used Venus gravity and needed 6 months to see Mercury for the first time. The Messenger probe worked even harder, using Earth and Venus multiple times for acceleration, taking 6.5 years to finally enter orbit. The latest Bepi-Colombo spacecraft is still wandering through space right now. You've probably noticed the problem. Flying past Mercury is easy, but staying is extremely difficult because there are no brakes in space. Deceleration requires burning precious fuel. Worse still, Mercury has no atmosphere, so you can't slow down using air friction. Every braking maneuver is like dancing on a knife's edge. Add the sun's scorching heat right next door, and the journey becomes a test of patience and engineering. Sometimes, taking a longer route is actually the fastest. Leaving Mercury, let's look at the brightest object in the night sky, Venus. It appears gentle and glowing, but is actually a hidden hell world. Venus is Earth's closest neighbor, but don't be fooled by its beauty. Because of orbital changes, sometimes it's just beside us, and sometimes it's far away. But at least its orbit is nearly circular, easier to predict than Mercury's. So why do humans insist on exploring this hellish place? Because the shocking truth is, billions of years ago, Venus may have been an ocean-covered, habitable world, until runaway greenhouse effects turned it into today's nightmare. Lead melting temperatures and atmospheric pressure equal to 900 meters underwater. Studying Venus is studying Earth's most terrifying possible future. For this reason, humans have sent more probes to Venus than to Mars. The Soviet Venera 1 drifted for 97 days before contact was lost. NASA's Mariner 2 completed the first flyby in 110 days. Pioneer Venus 1 took 198 days to enter orbit. Venus Express flew 153 days. Why the huge differences? Because it depends on whether you just want to fly past or stay. A flyby can take just over 100 days, but entering orbit for long-term observation requires a more fuel-efficient path, taking nearly 200 days. And the most tragic stories happened on the surface. The Soviet Venera 9 and 10 successfully landed and operated for 53 and 65 minutes in 465 degrees Celsius heat and sulfuric acid corrosion, sending back the only real surface photos of Venus ever taken. Those data, bought with the probe's lives, tell us that some places can only be admired from afar. This world that may once have nurtured life has become the solar system's greatest warning, and therefore one of its most important targets. If Venus is Earth's cautionary tale, then Mars is the new continent waiting to be opened. Once our focus turns to the red planet, the question is no longer can we go, but how do we go, and who gets there first? This interplanetary expedition is speeding up under the collision and cooperation of NASA and SpaceX. NASA represents caution and safety, where every step is tested again and again. SpaceX, meanwhile, is the dark horse, betting on reusable rockets and disruptive technology, boldly slashing costs. Interestingly, these seemingly opposite philosophies are jointly accelerating humanity's arrival on Mars. So how long does it really take to get there? The most mind-bending truth. If you could travel at light speed, it would take only 12 minutes. But real spacecraft need more than half a year. Why such a huge difference? The answer is hidden in the Hohmann Transfer Orbit, the most fuel-efficient space highway. There are no straight shortcuts in space. A spacecraft must follow a carefully calculated elliptical path to meet Mars precisely. Even worse, the Mars launch window opens only once every 26 months. Miss it, and you wait 2 years. Right now, a one-way trip to Mars takes about 9 months. But that's only one direction. If you include waiting for the return window and flying home, a full Mars mission exceeds 21 months. And the real challenge begins after arrival. Months of deep space flight exposes astronauts to radiation, mental stress, and zero gravity. That's why speed matters. Reducing time protects lives. This is why SpaceX's Raptor engines and reusable heavy rockets carry such high expectations. If they succeed, reaching Mars will no longer be a technical problem, but a strategic one about cost, risk, and timing. A manned landing on Mars may well be witnessed by our generation, leaving Mars' red deserts behind. We face the true giant of the solar system, Jupiter. You might ask, why would we go to a gas giant with no solid surface? Because Jupiter itself is a cosmic life laboratory. It has continent-sized storms and a magnetic field that could hold more than 10 Earths. Even more stunning, its moons form a miniature solar system. Europa's subsurface ocean and Ganymede's salty layers may both harbor life. This could be where we first find aliens. But reaching Jupiter is unbelievably hard. The distance is so great that driving at 110 kilometers per hour would take centuries. More importantly, the journey depends on whether you just pass by or stay. New Horizons only needed 405 days to fly past Jupiter, using its gravity to speed toward Pluto. But to be captured by Jupiter and orbit it requires enormous sacrifice. Galileo needed nearly 6 years to arrive. A long journey in exchange for years of deep exploration. Can humans go to Jupiter? The harsh truth. With current tech, one-way travel takes almost 6 years. Just food for 4 astronauts would weigh over 20 tons, not counting water, air, or radiation shielding. As Earth shrinks into a pail dot outside the window, astronauts endure years of isolation in a tiny capsule. The psychological trial is worse than the engineering. So for now, only robots can go. NASA's Europa Clipper and ESA's JUICE mission are on their way, spending years just for a chance to stay and study the icy moons. Jupiter's gravity teaches us that in deep space, the fastest way is often the most patient way. Past Jupiter, You finally see the solar system's most majestic sight, Saturn. Its perfect inner rings look beautiful, but behind the beauty lie countless mysteries. How they formed, why they change color, whether they glow on their own. Even more fascinating, its moons, Titan with liquid methane seas, and Enceladus with water plumes, both likely to host life. But first we face the despair of distance. At closest, Saturn is 1.2 billion kilometers away. At farthest, over 1.7 billion. Every mission becomes a marathon across time and space. The most shocking contrast, fly past versus stay. New Horizons cross Saturn's orbit in just 2 years and 4 months. Voyager 1 used a perfect planetary lineup to do it in 3 years and 2 months. But to be captured by Saturn takes unimaginable patience. Cassini took 7 full years, 2 assists from Venus, 1 from Earth, then a gravity boost from Jupiter, before finally entering Saturn's rings, and then spent 13 years writing Saturn's encyclopedia. Can humans go? The answer is still cruel. A manned trip would take 8 years one way. That means astronauts would spend their youth locked in a metal tube, carrying nearly 10 years of life supplies. Returning would depend on Jupiter's gravity at the right moment. Planning such a route is harder than anything you could imagine. That's why we rely on robots. Cassini's 13-year vigil gave us unmatched knowledge of Saturn. For the foreseeable future, only metal emissaries can decode the secrets of its rings. Beyond Saturn, space grows colder. After passing its shimmering rings, you reach the 2 blue giants of the solar system, Uranus and Neptune. They look like twins, but hide completely different cosmic codes. The most shocking truth, their blue color is not from oceans, but from methane absorbing red light, an optical illusion. Beneath that similarity lies total contrast. Uranus is a lying down giant, tilted 98 degrees, spinning on its side, with a misaligned magnetic field and frozen interior, as if struck in ancient times. Neptune, however, is full of rage, winds up to 1,700 kilometers per hour and boiling dark storms. Even stranger, their moons. One of Uranus' moons has cliffs taller than 20 kilometers, showing the power of ice geology. These discoveries matter because ice giants like them are the most common type of planet in the galaxy. Understanding them is decoding how most planets in the universe are born. That's why scientists have locked onto their next major mission, the Uranus Orbiter and Probe. If it catches the 2031 launch window and uses Jupiter for gravity assist, it will still need 13 years to arrive. Miss it, and you wait more than 15 years. Yet compared to Neptune, Uranus is easy. In all human history, only Voyager 2 has ever seen Neptune up close. In 1989, thanks to a once in 176 years perfect planetary alignment that allowed continuous gravity assists. Again, you face the gap between passing by and staying. Voyager 2 flew past Neptune at 15.5 kilometers per second. Capturing it into orbit would require fuel, exceeding 10 times the probe's own mass, with braking taking 1 to 2 months. The harshest reality. Even with the best trajectory, a manned mission to Neptune would take 24 to 28 years, with 2 to 4 years spent just slowing down. Including return fuel, over 90% of the spacecraft's weight would be fuel. This is the deadlock of current space tech, the tyranny of the rocket equation. These 2 blue giants tell us that some truths require a generation of patience. Some frontiers belong only to robots that never plan to return. Now you've reached the edge of a solar system. Before you stands Pluto, the frozen kingdom. This demoted dwarf planet holds astonishing truths. Here, the sun is just a bright star, and your commands take 4 to 7 hours to arrive at light speed. NASA's New Horizons, flying at 16 kilometers per second, needed 9.5 years to finally reveal Pluto's icy heart. But the most shocking comparison, a manned trip would take 35 years. What does that mean? If you depart when your child is 1 year old, they'll be a grandparent when you arrive, and you'll be a great-grandparent when you return. That journey could take so long that 2 generations of astronauts would change crews inside the ship. Choosing your travel partners becomes more important than choosing the route. Looking back at this interstellar trip, one core truth emerges. Distance is not just space, it is energy. From Mercury's 4 months to Neptune's decades, the answer always depends on whether you just want to rush past or stay. That's why gravity assists remain the essence of space travel. They decide whether you take a single snapshot or begin a whole season of discovery. But we are pushing the limits. Solar electric propulsion gives long-term thrust. Solar sails catch photons. Nuclear reactors provide continuous power. And in the future, laser sails and ion engines. Each technology is redefining possibility. From Mercury to Pluto, from Venus hell to Jupiter's storms, every journey is a monument to human ingenuity. We have learned to ride gravity, to trade patience for knowledge, and courage for new borders. So after this grand interplanetary voyage, ask yourself, if your cosmic passport could hold only one stamp, where would you choose? The shadow of Saturn's rings? Europa's cracked ice? Uranus' stillness? Or Neptune's storms? Leave your dream destination in the comments. Maybe someday human footsteps will reach it. After all, every great journey begins with a simple thought, I want to go see.